Alright guys, welcome to AtCoder for another AtCoder beginner contest. It has just started. As you can see, I'm a little bit not prepared for this, but that's fine. We'll type our template quickly. And hopefully without many mistakes. Unfortunately, I was not fully ready for that, but it's okay. Where is it? 213. This time we have 8 problems, just as the last time. So some of them will be quite challenging, but some of them will be quite easy. So problem A, Bitwise Exclusive Or. We are given integers a and b between 0 and 255. Find a non-negative value, a non-negative integer x such that a XOR integer c such that a XOR c is equal to b. Well, as we all know, the main property of the XOR comes into play, and that is like if a XOR c is equal to b, you can XOR with two sides with a, let's say. So therefore you get something like this, and then you can cancel out a's. So c is just equal to XOR of a and b. Hopefully you were able to figure this out from the example here. You can quickly check that c is just equal to XOR of a and b. Not exactly. Let's do this. Probably doesn't matter, but whatever. We'll need to compile at some point later, but not now. So problem B, Booby Prize, and players who are numbered 1 through n have played the game. Player I has scored AI, and the player with the smaller score ranks higher. The player who ranks the second lowest will receive a Booby Prize. Who is this player? Answer is an integer representing the player. Okay. So we have an array. We read our array. What do we expect to do next? Second lowest rank, which is second highest score. Second highest score is player number 3. Okay. So we could just add indices and sort pairs and just take the second maximum, but I assume that we can also... Oh, there is nth element, right? Nth element. I want to do it the STL way. We'll probably also just write a for loop because no, let's do it this way. So I want to have an index of each element. I probably want it to be this second entry, so like this. Then I can say ends element of what? Of AI begin, I imagine. But I also want second highest, so a R begin, AI. Can you take next off reverse iterator? I wonder. We'll have to compile that, unfortunately, to find out. Alright, and if this works, then I can just take AI1 at second. Oh no, because I would need to take second from last, and I don't really want to get into the details, so I will just change this here, so they get sorted in descending order, right? So this probably works if it compiles. I should change that. Oh, I also probably should need to print +1. Alright, so far so good. 5. Alright, let's submit. So ends element is like partial sorting, which is better, faster than sorting the entire array. And hopefully I didn't make any stupid mistakes. Okay, not this time around. Problem, but we spent quite some time there, unfortunately. Problem C, reorder cards. We have HW cards arranged in the matrix with H rows and W columns. For each row, the card at AI's row from the top and BI's column from the left has a number I written on it. The other cards have nothing written on them. We will repeat the following two kinds of operation on those cards as long as we can. So if there is a row without a numbered card, we remove all the cards in that row and fill the gap by shifting the remaining cards upward. If there is a column without, we remove the column. Okay. Find the position of each numbered card after the end of the process above. Right? That's not... Okay, that is just... Like, you need to sort X coordinates and Y coordinates separately. In a way. Nothing smart there. So you see that they provide input in this order, which is convenient for reading the input, but is not convenient for solving the problem. Like you can read just like this, but you see, we'll need this for answers. We'll need indexed pairs AI to figure out like once we sort, there is no way for us to go back unless we have indices, which is exactly what we are doing here. So I say like AI is equal to pair of AI and I. Once I sort, I will know what was the original index of the elements that I got. So all of those have the same type, so I will just place them here. So, oh, actually that is incorrect. I should take first here and second here. Now once I sort AI and also BI, the point is that I can loop over them like this. Oh, actually that is a bit tricky. Alright, not that much, however. So see, our rows start with 0, and then we do the following. So for like A and I in AI, and our A, let's say, starts with -1, I guess. That's like because they are not distinct, I have to keep track of how many different values of I saw. And I want to do this with two variables. So AP is previous I. If A is not equal to AP, then I increment row, and AP gets A. And also answer at I first gets row. More or less the same code will go for BI. I need previous B column, BB here and there, B column, B, once again B, second, and column, and once answer is fully filled, I can just rather like that over rows and columns in the answer, and I will print them like that, I believe. Alright. Sounds more or less reasonable. Hides previous local declaration. Yeah, probably I should have gone with A and B here and here. It is not a compiler error, I believe. But still. So 2, 1, 1, 2 is exactly what we should see here. Here we should see, yeah, exactly that, so makes sense. Hopefully I did everything right. Okay. Because there are so many problems, I try to go through them rather quickly. Hopefully that does not really affect the quality of explanations that I'm doing, but it may affect the length of the explanations. The problem D, Takahashi Tour, the Republic of AtCoder has n cities numbered 1 through n and n-1 roads. So therefore it's a 3. It's a 3. Takahashi will depart city 1 and have a journey by repeating the following. If there are unvisited cities that are directly connected to the city Takahashi is in now, he goes to the city with the smallest number. Otherwise, if he is in city 1, he ends the journey, or he goes back to the city he was in just before visiting the current city for the first time. Find the sequence of cities visited by Takahashi in the order he visited them. Well, that sounds just like DFS, but with an extra condition that we have to go to every city in order, right? So what it sounds like is something as follows. Instead of having vector of vectors of ints, we'll have vector of sets. Now we loop over our n-1 edges. JA gets inserted B, GB gets inserted A, root is 0. Now we have our DFS, which won't return anything, will take in the number of vertex we are currently in. So that's this, then we call DFS of 0. Want to print them space separated, so I guess I will also have to print a new line just in case myself. So what does DFS do? Well, we also need a vector, like if the vertex is used, original nothing is used. Yeah, DFS of root. I like to define root because sometimes it changes, so I just like to have a variable for it. Although here it's completely unnecessary, I believe. So first things first, this gets true. Then for all neighbors, if they are not used, we call DFS of them. With an extra twist, so we definitely print a vertex here, but also we print it every time we go out of the DFS, I believe. Let's just quickly check if this is what it should be. Ooh. So apart from all indices being shifted down by 1, it appears to be correct. So I will go and fix that here and here and just submit. Yeah, problems ID definitely became easier after the introduction of new problems. I imagine because you kinda need to solve all of them in like a reasonable amount of time. Right, so we spent 20 minutes out of only 100 minutes that we have for this contest, so like it's not exactly the fastest way to do everything. Now the remaining ones are not necessarily in order. I believe last time problem F was harder than problem G, even with G having higher points value. Problem E is stronger Takahashi. So if we get stuck on one of those 4, we should definitely consider reading the following one. This first 4, it kind of doesn't make sense because I would imagine that you intend to solve them either way, so there's no real point in skipping. Problem is stronger Takahashi. There is a town divided into a grid of cells with H rows and W columns. The cell Sij is opassable if it's a dot or blocked if it's a sharp, as usual. Takahashi will go from his house to a fish market. His house is the cell at the top left corner, and the fish market is the cell at the bottom right. Takahashi can move one cell up, down, left, or right. He cannot leave the town, he cannot enter a block either. However, his physical strengths allow him to destroy all blocks in a square region with 2 times 2 cells of his choice with one punch, making those cells possible. Find the minimum number of punches needed for Takahashi to reach the fish market. Ooh, I'm usually bad at such problems, so you should read the next one as well. Let the similarity f of x, problem f common prefixes. I actually immediately regret my decision to read the problem. But let the similarity f of x and y between two strings be the length of their longest common prefix. Okay, we can compute that quite quickly. We are given a string s of length n. Let si be the suffix of s beginning with the ith character for each k find. It sounds like something to do with suffix array. Also, time limit for that problem is increased from 2 seconds to 3 seconds. But it definitely has something to do with classical string algorithms. I remember there was an LCP array. Auxiliary data structure to the suffix array, yes, stores the length of the longest common prefixes between all pairs of consecutive suffixes. That's what I was thinking about, consecutive suffixes. Oh, in a sorted suffix array. In a sorted suffix array. Why does it matter? No, rather I should ask myself how to use this information to solve the problem. So if this is like this, right? Because I take a similarity with everything else, right? Oh, I also take with myself, that, okay. Speaking of which, is AtCoder library capable of finding LCP array? I imagine it's not. No, but here it should, like with suffix array, you should definitely see LCP array, right? Longest common, yes. LCP array, yes. No, but how to use the array to solve our problem? So I imagine if the, like, what is actually for Mississippi? That's kind of more interesting question. So for Mississippi, right? What are the suffixes? I, P, PPI, IP, CP, CP, also you get ECP, S. Okay, that is a good test for suffix array. Like I would imagine this is like, it makes me more confident that problem is actually about suffix array, that we have Mississippi as a test case. It goes even further, so like ESS. That's ridiculously long, okay. And we have also Mississippi on its own, funnily enough. Is it actually the spelling of the Mississippi word? Yes. Ridiculous. Okay. So they are not actually in sorted order right now, but they are more or less close. So the thing is, like, this one will have 0 because it will correspond to, okay, like who comes first? I don't know English alphabet. I definitely comes first, then M, P, and S. Should write it down. Wait, does it? S comes after P, okay. So like what we will have is I on its own. Then next is EP. The length of the longest common prefix is 1. Then something like ECP comes next with, after this, also have long length of 1. With this one, however, it has length 4 in common. Next one will be not I, so the common length is 0. The next one will be Mississippi. It also has 0 with the next one, which is PI. But PI has 1 with PPI, which has 0 with everything that starts with S. So, but S, what is the relative order of those? I imagine that is CP, and then, so this one, this one, this one, this one. So, this with this, they have 2 in common. This with this, they have 1 in common only. And this with this, they have 3 in common. So now, if we consider a position, like actual suffixes are, those elements are in between suffixes, right? Now what I think you want to know, like, if you're given an entry like this one, makes more sense. And you go to the right and to the left and you want, like you can't take more than, wait a second. Let's go with this one, right? So this one is actually this. Going to the left immediately it has a value of 2, alright. Going to the right it only has a value of 1. So what I think we take like this element, then we never increase but we can decrease. And take this element, we never increase but we can decrease. So like we start rolling a minimum both ways and sum all the values. Unfortunately, just doing this is too slow, I would imagine. Because that's still quadratic. Well, it's not cubic, at least. But we need a linear time algorithm for this. Okay, there should be like an array algorithm for doing the remaining work. Alright, but let's start with just copying suffix array. So, wait a second, what about a linear time suffix array? There is one. I know there is one. Okay, so why is it so badly typed, honestly? Like, why would you break? This is just so annoying to copy paste right now. Okay, I will clear that for now. We definitely need this. Also need this. Man, one thing I really dislike about those bodies is how they make use of some strange variables. Okay. It is not the best time to discuss. So definitely need this. And that's too slow, obviously. I don't think we'll need this, but LCP. Yeah, I don't care. I think I had enough memory already. Oh, that is so annoying. Like it expects C and log n to be in, like, why would you do that? You defined everything inside this function and now you want to make use of those variables. That is just so bad. Okay. What is the type of C? What? Oh, because it's a string? No, I don't. Why would you write so bad code? Such a bad code, like. What the heck is C? Why? If the purpose of this code is to be. Remember the intermediate results. Okay, so I don't want this and I want this instead, right? It's annoying that you have to sync when copy pasting code. Alright. Now this part should be simpler. P construction of S and P. Who is P? So P is suffix array or what? Ah, yes, okay. So first we take suffix array. They call it sort sec. Ah, yes, because suffix array is also the same as cyclic shifts. No, but that means that you yes. I missed an important detail here. Like it's good thing that I remember that you need to add this. So here I construct this, then I construct this from this and this. Oh, and then I have to work with LCP array and suffix array to compute the answers. It sounds something like largest rectangle in histogram, but it's not. But actually, why is it not that? Oh, I think I just use a monostack, right? Yeah, we just use a monostack, I'm pretty sure. That's supposed to go like this. And lines. Right. How about modding? Modding is not supported, so this should be long. No, because like if the string is all like 1,000,000 copies of letter A, and the answer can clearly be up to 10, 5 times 10 to the 11th. So that's that. I wonder why. Okay. Now I want to have two monostacks, I believe. One that goes from left to right, another one that goes from right to left. I would also like to debug this a bit. Not because I don't believe in CP algorithms, but because I want to see suffix array for Mississippi. And also LCP array. So with that out of the way, I guess so. First, I should update. I should also keep pairs. No, I will just keep indices, but like okay. And LCP at mono top back, because it's a vector, is greater than LCP at I. Maybe it only has to go up to this point. No, it will have one extra element for like $sign, right? For the shift it starts with a $sign, hopefully. It will. So here we say mono pop back. Then what are we expected to put into the answer? So the answer should be incremented by I feel like I may just need another vector just for left answer. So here I'm thinking mono back. Actually, if mono is empty, then it's not clear what I'm adding in. Mono empty. Otherwise, we can access back. Probably LCP at I. No, probably suffix array at I. It's left of suffix array at mono back plus I minus mono back times LCP at I, something like this. And if mono is empty, then mono back is not possible to access. This thing is 0, I believe, and this thing is also 0. Should add this one in and this one in. No, I should do more or less the same thing with right. Oh, that's why it was scoped, because I didn't want mono to be shaded. The only difference I would like to hope is that we loop in the reverse order. Not quite right. We also need to make sure that here we put it into the right spot. So that probably won't work. But hey, we can try. Those first two I don't care much about. Now the last two are more meaningful. On lines 83 and here and here. Alright, 2 warnings for size T conversion, that's fine. Alright, let's go. So that accessed an element that does not exist. So LC suffix array is A, then B, then BB. Now, except for that accessing an existing sync, it's almost fine. Because yes, LCP is short, so this already has to happen, right? That's all I'm wondering. Oh, I didn't push. You are absolutely right if you notice that I didn't push. What I should push is I, right? Just always push I. I wonder how that got in place. I actually don't wonder, because here the index is the other way around. Oh, I just have it here, right? Oh, I entered the wrong string. That is incorrect. And I don't quite see how it happened. So the way I was thinking is like, well, this and this should get +1. Oh, probably because here it's actually this body who is getting the points, right? Am I right? So suffix array +1. No, suffix array +1 here, of course, because otherwise it just doesn't make sense. Wrong one. I like how we just completely ignored problem E to solve a complicated problem. Alright, that actually fixes it, because now we can just add I +1 for the length of the ourselves. So like every prefix we also count it with itself, which we don't in the approach that I implemented. Now we do. Of course. How can I be that stupid? Vn minus I is the length of the else suffix, of the ice suffix. So 3, 3, 2, more like it. 11, oh. Does not look great. Does not look great. Or maybe it's the other way around. Maybe it's not here that we need to add +1. Maybe it's here that we need to add +1. Because like surely we need to add +1 somewhere, because either the left or right positions are offset because the LCP elements come in between other elements. So 11, 15, 14, 18. We have a huge number here. And if, oh, maybe we don't add 1 here. Like, because that's, I was thinking like what happens if you skip a 0, and you should not skip a 0, I think. So how about that? How about that? Still not great. Maybe we should actually start thinking. What do you think about that? So, like here we are trying to compute something over. Yeah, I should just print those, right? I should just print those on their own. So left, here goes left, here goes right. ABB, suffix array whatever, LCP, so those come in between of those, right? And then I say like, okay, I will go through LCP left to right. So actually at this moment, my answer should get 0, which it does. This moment my answer should get 0, which it does. At this moment, however, I see this, so my answer should get 1. And I say, okay, I'm going to go over LCP from right to left. At this moment I see nothing to my right, so I get 0. This moment I see 1, this one, so this gets here. At this moment I see the 0, so I can't go past the 0, that's why I get 0 here. In Mississippi, however, suffix array looks like this, LCP array looks like this. Then I go from left to right, so tens and the last one I see nothing to my left, which is correct. And then after this I see 7, it has 1. And it should count this one. Which is 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. which it for some reason does not. Like, I don't know why it doesn't count 1, this one. It should. Why do I don't see this one? But at 4, I see 2 ones. No, this is not 4, this is 4. No, but here actually ith element of the suffix array should get something, right? Yeah, I don't see why it should not be this. When we go from right to left, then it actually should be the next element. So my initial guess was correct, it appears to me. Oh, it broke. It broke for some reason. I wonder why. Oh, because this is clearly like should be within here. What? Okay, so we spent like a long time here. And this one somehow gets a dramatic number of points. Suffix array 2. Oh, because, here it's n minus I, n minus 1. Minus 1 minus I, and minus 2 minus I. Okay, so that explains one of our strangest things, that we had a massive number somewhere. Much closer to the actual solution now. What about this example? Still works, so not a great example. So suffix array at 1 is already wrong, this one. So going to the left, it should collect 6. 6, which it doesn't for some reason. And going to the right, it should collect, no. Yes, Yes, going to the left, it should collect 6. Going to the right, it should collect 0. Surprisingly, this is not the case. Maybe it's because this is like this. No, it still collects 4 points going to the right. I don't understand why exactly. Should definitely collect 0 points. Should collect more points going to the left. Okay, so what I was imagining about mono stack here is that we will put 1, 1, and 4 before we consider this one. Oh. Should we assign before we do the check? Before we modify the stack? Oh, that's tricky. Now it gets 5 points going to the left, which it shouldn't. It should get 6. And here it should get 0. Gets 8 points going to the right. So what happens is we add this, no, we process this value, it gets nothing, because it's the last one. And we process this, then we look at 5. So 5 is this index. In the right array, however, is it LCP I plus 1? No, mono is empty only if it's the beginning of the entire thing. So I should instead write like this. Definitely not a 500 problem if this is the intended solution. second element gets 0 going to the right, which is correct. This body should get 3 going to the right. Fifths, right? 1, 2, 3. No, 0, 1, 2, 3, 4, 5, 3. It gets 3. Now third element should get not this many points. Third element should get only 2 points, because we add this value in. LCP here is greater than LCP here. So we remove it and we push this index. Oh, so here we don't need I+1, right? Because that's we are taking like the answer 1 too far. So third one gets 1 point now. Sixth one should get 4. No, third one should be getting 2 points. 1 for this and 1 for this. The state of the monostack is like there is 1 and then there is like nothing. Oof, why is this so complicated? But I really want to solve this problem instead of other problems. I don't know why. Because it feels so close, and yet so far. Yeah, I may just need to do it accurately. Like here's our LCP array. Going to from the left. This is probably not the best way to print them, right? So what I actually want to have is this will be much simpler to debug. You'll see. Now here just equals. Right. R will be in reversed order, but hopefully you can still understand what's going on. Hopefully I will be able to understand what's going on. It is definitely a yellow problem. So R is in reversed order, unfortunately. Left is the correct order, but it's missing the first one, first 0. Well, that's incorrect. You see, what I wanted from left is to be the following. So LCP is like this. So I want from this one, there is nothing to the left. Then 1, then 2, then 6, and 0. 0, 1, 0, 2, still 2, 5. That's what we want from left. For the right one, we want from the first 0 and 3, then those two get A2, those get A4, 0, 1, 0, 0, 4, 2, and 3. That's what our aim is. I believe this is manageable with monostack, right? What's the answer? I need to find this the element, the previous smaller element, which is L at say mono back. So mono back is the previous smaller element of LCP. And I can take that answer, just take it. And what I want to add is I want to add the difference times LCP in my position. Probably I want to update stack before I do anything. Because otherwise it's not necessarily the previous smaller element. But now everything is empty. So I want to push before, after. I want to push after I process the current entry. That makes sense. I may need to print it every time because otherwise it becomes like it skips some elements, some that are 0. Like 0, 1, 5 is incorrect. Oh, it skipped the first 0, so that's okay. But then it should be one more. It should be one more for each of those. Well, it's probably because I didn't count this length here. So what if I say plus LCP at mono back? I also should say it here, plus LCP at mono back. No, that's too much. LCP at mono back should be already in answer, right? Be already in the answer. So 1, 0 is skipped. So this are one less than they should be. But everything else is technically correct. Why are they one less than they should be? Because they don't count the first one? Why do they don't count the first one? They clearly just didn't count the first one, right? Also, I wonder what happens if I just copy paste this and assign to R, but I reverse LCP in between. It is more reliable, right? If I do this, it's more reliable than changing the entire indexation myself, like the second time. Let's see if this helps. Like this is still incorrect, but I think it's closer to being correct. This is right, the first 0 is skipped, then 3 to 4 is actually correct, then 0, 1. No, this gets messed up. This gets messed up. No, wait. No, no. Okay, so first 0 is skipped, then for some reason the element is 0. Oh, maybe because... Oh. Here I need just substitute 0 instead of this, right? And also this is 0. I plus 1? Is it I plus 1? Is it I plus 1, I wonder? Let's pretend that this is I plus 1. Oh, so painful. Should have studied more. Then I would have understood everything that goes on here instead of just simply trying to fix something. Okay, so it's still missing the first 0, but everything else is correct. It's missing the first 0. But then it's correct. Because it's missing the first 0, I wonder if it should put it to the next entry of suffix array. And same goes here. And same goes here. Oof, tough one for me. I'm not particularly good at string algorithms, and apparently this went out of control a bit. Oh, okay. Now this is okay. That's a different bug. Not related to the changes we made. That was not f.exe, it was something else. So, except for the first 0, they looked correct, right? For this body, it looks like we got too much. Maybe this one shouldn't actually be +1. Or rather, one of them should not be. Which one we will figure out soon. Very close. Except for this one got a little lower than it should, and this one got a little higher than it should. Why did that happen? I wonder if we see the same situation here. So one of them is 1 too small and one of them is 1 too high. Which one? Which one? Here it's index 0 and index 9. Also, indices 0 and 9 go here and here. And they are wrong by 1. Wait, does this actually work? Like when mono becomes empty, it is empty originally. After that we always push back a value, and it only becomes empty if our value is greater than everything before. So if our value is the new minimum, then mono can become empty. I should just do this. Empty at I equals I. Should honestly just do this. Oh, not minutes. I feel like we are very close to solving this problem. So mod became empty at index 3 once again. 1, 2, 0, 1, 2, 3. Because that's the smallest element we've seen in LCP array so far. Then it kind of doesn't matter because LCP Speaking of which, how did it so happen that we don't have to reverse suffix array here? Excuse me? Isn't it wrong to not reverse it? Fascinating. No, surely it's not. Looks like it's not wrong. I don't understand how it can be possibly not wrong to not reverse it. Also, to be honest, I don't understand why we don't add one here. If we add one there, we should also add one here, no? Well, that is clearly incorrect, but like this. Now that looks like a correct answer. Alright, let's just remove all the C error, all the debug output. Only 10 minutes remaining, but it was worth it, I think. If this works, then I will feel very happy about this contest. It's the first time I solved F during the contest in a while. So if this works, then I'm happy for today. Let's see. Yes, I know we must be terrible in standings because I believe that this one is not that difficult. Solving problem F was probably not worth it here. Yeah, but you can see that pretty much everyone solved E, but only like 100 people solved F. So if we can get E, then we will be in top 200. The only problem being that we only have 10 minutes to solve that one. Okay. This one we can close. This one we need to open like that and like that. I remember it was a grid problem, but I actually remember everything that happens in this problem. We needed a minimum number of punches to get to some cell. We remove 2 by 2. We want to find the minimum number of punches. You cannot move diagonally. What's the trick here? We can compute H and V are not huge. So we can compute like all cells that are reachable from the beginning with 0 punches. And we can say like, okay, we have 1 punch that creates a whole 2 by 2. It should be placed like it's, if you were to delete just 1 times 1 blocks, then it's fairly easy, I believe. It is just 0, 1 BFS, right? To compute the shortest pass. 2 by 2, however, it's not clear. It is not clear. DP should not work. DP should not work because this test clearly shows that there are strange paths go like this. So it's a graph problem. It's a graph problem for sure. I don't understand how this relates to 0, 1 BFS, if in any way. Also, it looks like people are actually taking quite some time on this problem. So even top guys take like quite some time. So I don't think that we are solving it on time, but let's try to solve it at least shortly, in a short overtime. Well, for Matvey it actually took 18 minutes. don't quite understand. The thing with like 2x2 cells is that they basically allow you to move diagonally, which is kind of questionable. Alright, I may have figured out the approach for this one. So we'll need a distance that is originally like infinite. Let's say just d. d of 0, 0 is equal to 0. And we want to print d of height minus 1, width minus 1 over 2. Over 2 because I will compute distance in half steps. Also, I need actually the BFS, I will need it. So it starts with 0, 0. Then while BFS is not empty, I take row column from BFS, I remove it, select for what? Neighbors, in neighbors of row and column, actually you see if distance of RC is odd, then it means that we are at first half step, and instead of looping over such neighbors I can update such neighbors. Otherwise we are at the first half step, so like here we are in the process of breaking a block, but we haven't finished it yet. Here we already broke the entire block. So this takes in a row, a column, returns a vector of pairs. Sorry, 1 second later. 1 second later. Maybe not 1 second, actually 1 minute or so. So this returns what? Right minus 1, column minus 1, row minus 1, column, row minus 1, column plus 1, row column minus 1, row column plus 1. Yeah, I know, it's unfortunate that we didn't solve it on time, but we'll try to solve it immediately. So like this, like this. Now I also want side neighbors. Now side neighbors are only 4 of those values, namely those 4. We'll also need the functions that makes sure that a current cell is a valid cell, which is not really complicated. It's just that 0 row is at least 0, row is less than height, column is at least 0, and column is less than width. So if our neighbor is valid, then distance, if distance at neighbor, I can just combine them, right? If distance at neighbor is less than distance at row column plus 1, then, no, actually, if it's greater than that, and it should get that, and BFS and place back row column. Actually, this is the same, like the only set the thing differs is the set of neighbors that we loop over. Now here, we are in the process of breaking a block, so we don't exactly care if the space is occupied or not. Here, however, we care, so like, not only it needs to be valid, there are several cases to consider. So, if this is a free cell, if it's free to pass, and if distance is greater than that, and we set it to this and go. Otherwise, it's blocked, and we can use one of, like, we can start a punch here to go this way. Yeah, sounds like this is what I had in mind. I should prove that it works somehow. Okay, the answer is 1 for this one, the answer is 0 for this one, the answer is 5 for this one. So hopefully that works. Yes, okay, good. So we were only 4 minutes short of solving first 6 questions, which could have put us in top 200, I believe. Yeah, like you can see, that is actually interesting. Like both Matvey and Oleg are international grandmasters in code forces. So you can see the level of the problem. That is definitely yellow. That is definitely yellow. Like everyone else solved E, which I understand. I needed like what, 14 minutes to solve it, probably faster than everyone else actually. But yeah, that was more interesting problem to solve. That's why I went for it. Okay, this has not updated yet. Should we take a look at like G or something? I'm a bit, oh, actually Vika took part today. Okay, that's interesting. Yeah, it's such a shame that like, I don't know, 0-1 BFS problem is the same as LCP array. Dude, an AtCoder library doesn't even have LCP arrays, so like you have to know that it is on CP algorithms. So that's insane. To write this as 500, I don't understand how it can possibly be. Like everyone can solve this 100, but only international grandmasters and people who skipped E can solve this. So that is very strange, very strange. Oh, there are 3 pages of Ukrainians. Okay. how most of them didn't come to the contest. Okay. Yeah, so like in terms of contest strategy, that was the worst choice. But in terms of solving interesting problems, that was definitely my first priority. Yes, but 0-1 BFS is a nice thing to know. So what I do here, just to clarify, is like there are two phases to the punch. First, we start a punch. When we start a punch, we break 1 by 1 square. The second phase is we can get from that square to any adjacent by point. So like diagonal adjacent as well. So that's what happens here. If we don't, then so that was like second phase of the punch. Now here, if we just go, if we are not in the currently engaged in a punch, then we have to, and then we go into a neighbor cell. If it's free to pass, then we just pass in like in 0 part of the 0-1 BFS. If it's occupied, then we are going in like, then we initialize a punch. We get into the first phase. And the distance is like the number of phases of punches that we made, so therefore we divide by 2 to get the actual punches. Actually, that's incorrect. That is incorrect. Hold on a second, that should be this, actually. I don't know how he didn't caught it. Like, that's incorrect. That should be obviously that should be rounded up. What I was thinking about. Wait, so are the tests weak? No, but like obviously it should be rounded up. Right? Right? Okay, so that's insane. Like those things definitely produce different values. Man, like no. Let me run the old one first. So what I'm thinking is 3, no, actually like 5, 5. Then completely occupied grid. The answer is 3, right? If I now recompile, oh, it is already copied. No, okay. That still sounds very suspicious. Okay, what if we do like a rectangular grid? So this one is 2. Oh, it doesn't matter because the last cell is always a dot, and therefore it's not possible that we started a punch which we have not finished yet. Oh, that's smart. Okay. So like there is no difference between those two, but that's pure luck. Like if the last cell could be blocked, then we should have rounded up, of course. Yeah, but the last cell is always free, and therefore it means that we got there either by this transition or this, both of which make the distance even, so it doesn't matter if you add one or you don't. So that's it. I'm a bit tired to keep going with problems G and H. Maybe I will solve them some other time. Okay, it looks like we are not seeing them on Kenku soon enough, so guys, hope you enjoyed this video. Hope it helped you, especially with problems E and F. A through D, I believe, was quite easy for all of you. I hope that by watching this and probably other competitive programming channels, you are already good enough to solve A through D without much trouble. As like we got them in 20 minutes, right? So They were not particularly smart. You just need to do what you need to do. Like here, you need to know what XOR is. Here you need to know how to partially sort, or you could just sort the entire thing because it fits into the time limit. Yeah, so just like add indices and then sort in the right order. Nothing smart. More or less the same thing here. You need to realize like, okay, like if I'm getting rid of all columns and rows that don't have anything in them, then I only care about the order, relative order of the cells that have something in them. And I care about rows and columns clearly separately. Those are separate values. So the problem becomes like, okay, let's ignore the row column thing for now. Let's imagine that we have like a 1 billion elements long array, most of which are empty. How do you find order index of every element? Well, we just sort and then we check for equal elements, which consecutive equal elements, which is kinda, but still, you should be able to figure this out in like 10-15 minutes. Problem D, they literally described the DFS, which with specific order of vertices, so I just used set, which implements this order straight away. I could have used vector and sorted every vector, but I believe this, I'm not sure which one's faster. But this was fast enough, so I don't really care. And problem E, 0-1 BFS, good fit for 500 problem. 0-1 BFS with a twist. So especially if you're getting ready for programming interviews in Western companies, in USA-based companies, you should know about 0-1 BFS because it's like, I feel like it's an interview trick. Like, of course, it's useful in competitive programming, but I believe that it originates from some interviews. At least I saw it a lot, like on LeetCode and binarysearch.com. This is just like you see suffixes, you think like, okay, we compute the longest common prefix, and you think like, well, wait a second, what do I know about suffixes and longest common prefix? Well, it's possible that you don't know anything. Then you kind of don't solve this problem. It's okay. It's okay to not solve all problems. But if you know something, then you definitely know that it's an LCP array and suffix array. And you just find some code in either your library, some online source, something like that, to compute suffix array and LCP array. And then you realize like, what is the formula that I'm going after? It's like one largest rectangle in histogram where we took like a pivot, we extended it left and right to the first element that was smaller, right? But here we extend past, but they are just like trapezoid shape. Like largest rectangle in histogram, if you remember that city-shaped picture that often arises in certain interview websites, then we took a pivot there in the solution, and we said we extend it left and right as much as we can, as long as we come to the first element that is smaller. In this problem we extend, but it's like it's like a plateau, like it goes down. Like when it encounters a smaller element, it does not stop, it goes down. Still, everything that looks like this should be solvable with monostack, because you only care about those parts when you decrease. So that's clearly a monostack. Then you just have to figure out the specific details. Well, hopefully, luckily, I got it in time. Definitely not a 500 rated problem. I feel like the actual difficulty of AtCoder, those ABC those days is like F is actually still 600 points, G is 700, and H is 800. Because just looking at the standings, like honestly, 200 people and more than 1,000 here. You can tell that those problems don't have the same point value. And then only 50 people solved it here. So like, what are we actually talking about? Are you sure that we are talking about a Coder beginner contest here? because, well, I definitely enjoyed solving this problem, but it's not 500 rated, that's all I'm saying. You can see that international grandmasters can get a lot of penalties. Well, luckily for us, we debugged it locally, but still. Yeah, a clean contest once in a while. But other than that, those two problems are definitely different. You can see it overall, you can see it country-wise, you can see it wherever you want, if you have eyes. So maybe the point system is subject to change. I hope it's subject to change by the AtCoder team, because now currently it does not make sense to skip problems at this point. Which is kind of a shame, because like when every problem is worth more, then it means like if you solve F, then you are already above all people who solve E but can't solve F. So it's very rewarding to skip a problem. And I feel like it should be pursued. Like you want people, like ideally as a problem setter, I believe that your intention is to let people solve problems that they want to, not to enforce some specific strategy, which I believe what like AtCoder penalty time system is supposed to do. AtCoder is the only place on earth, well, it's one of several places where your penalty is your last submission time, and not the sum of the times. It does not enforce any strategy. Like I could have solved problems in order F, D, C, B, A. Given that I would have the same solve times for each problem, I would still end up with the same penalty. So it lets me solve the problems that I want to solve. Whereas this scoring system does not, because it means like F and E are equal on points, but F is incomparably harder. Yeah. But I'm happy that we got it. So this will be it for me for today. Hope you enjoyed, hope you learned something new. Maybe you will read about LCP array. Oh, which I unfortunately, I did copy the link to my to CP algorithms, so you will be able to read an article there. So that's it for me, and see you next time. Bye bye.